So your outlines, like I said before, these are your study guides, but this time we had sections that we kind of skipped over, so I'm just going to write over on here what is not covered. Everything else you need to worry about. But it's easier than writing what you need to worry about.
Yeah.
Short answer, yeah, the short answer. And there'll be someone else giving it. I won't be here on Tuesday, but it's the instructor who comes in after me. He'll be giving you the exam. And I've taken it already to make sure there are no problems with it, and it works as it should. So there should be no problems. Okay, so let's continue on chapter 16. Okay, so last time we start with problems on the problem level 1 on assigning oxidation numbers. So we're going to go for the level 2 problems, and then we'll hit how to balance oxidation reduction reactions, and then we'll start chapter 18 with whatever time is left. Sorry, this is playing with me. Okay. So let's kind of review how to do the oxidation phase. And this one, what we're looking at is identifying what is oxidized, what is reduced, what is the oxidizing agent, and what is the reducing agent. So it kind of takes, first off, a reminder as to what these terms mean. When I say something is oxidized, what does that mean? When it's oxidized, it's losing electrons, so it becomes more positive. What does it mean when something's reduced? Gains electrons, it becomes more negative. So reducing, just think of it, you're making something more negative. Kind of helps keep them straight. Oxidizing agent, it's the opposite. It means that it's something that's been reduced, and the reducing agent is something that's been oxidized. So they cause the other thing to actually occur. So if we look at this one, and we look at, first we have to figure out what is being oxidized, what is being reduced. The way to do that is to determine the oxidation numbers of all the individual atoms in this actual equation. So if we start off, let's look at I2O5 to start with. When we're figuring out the oxidation numbers for this one, which one of these do I automatically know? So do I know the oxidation number of I, or do I know the oxidation number of O automatically?
Oxygen.
Oxygen, right? What is it for oxygen? 2 minus? Okay, so we have a total of 5 of those for a total of 10 negative. So what does that mean the oxidation number for iodine has to be? 5 plus, right. So we have 5 plus because there's 2 of those, and that's going to add up to equal 0. So we have our oxidation number for I2 is 5 plus, for O5 is 2 minus. Going over here to CO, once again, which one of those do I automatically know my oxidation number? Oxygen, which is 2 minus. What does that tell us carbon's going to be?
2 plus.
2 plus, right? Okay. I2, what is that? When it's by itself, what is that going to be? 0.
1 minus.
It's 0. When they're by themselves like that, it's 0.
Oh.
Yeah. So in this case, it's 0. So you need to look, some of y'all I think need to look over those oxidation rules. Then we go over here to CO2. If I look at oxygen again by itself, what is it always going to be? 2, but I have 2 of those, so what does carbon have to be? 4. So we have 4 plus and 2 minus. So the first thing that you do is assign the oxidation numbers to each of the individual atoms. Then you look to see which one has been oxidized. So we said when something's oxidized, it becomes more positive. So what there becomes more positive? Carbon, right? It goes from 2 positive over here to a 4 positive over here. So carbon is oxidized. What has been reduced? What's become more negative?
Oxygen.
Notice I didn't say has become negative. I said become more negative.
Oxygen? I mean, oxygen?
Iodine. Iodine went from a 5 plus to a 0. So it has gained electrons. It has become more negative. So our iodine was actually reduced. So that's what's oxidized, that's what's reduced. Now, the reducing agent is going to be what? Think backwards, Lance. The carbon, it's going to be the compound with the carbon in it. So our reducing agent is our carbon monoxide. And what will our oxidizing agent be?
Oxygen.
CO2.
What was reduced? The I-205 is going to be our oxidizing agent. The iodine was actually reduced, so that means over here the I-205 is our oxidizing agent. So we have I-205. Okay, questions on that one? Yes.
For the reducing and oxidizing agent, are they always going to be?
Yes. Yeah. Yeah, we always assume we're talking about the reactants.
Okay.
Other questions on that? For once I beat all of you guys. Only because I hopped off and took side roads. Okay, so let's look at this one. Looking over here, starting with PBr3. What is PBr3? Not lead.
It's phosphorus bromide.
Phosphorus.
Phosphorus.
Not three.
Tribromide.
Phosphorus
Wow.
Oh, yeah.
Okay, guys, finals in less than a month.
Phosphorus.
Phosphorus tribromide. Okay,
Okay.
so which one of these do I know my oxidation number for?
Bromine.
Bromine, right? What is it going to be?
1 minus times 3.
1 minus. But how many of them do I have?
3.
So what does phosphorus have to be? 3 plus, right? Okay, H2O over here. Which one of those do I automatically know?
Oxygen.
Oxygen, we know is 2 minus. What's hydrogen going to be here?
2 plus.
There has to be 2 plus, but how many hydrogens are there?
1.
2, right? So it's going to be 1 plus each. Okay, then I go over here. What is H3PO3 called? You're asked about the amino acids, by the way, on the test.
Yeah.
So. Not phosphoric.
Phosphorus. Phosphorus? Wait,
No,
that's
phosphorus
Oh,
acid. Yes, those questions. I have 8 naming questions on the test for acid bases. So make sure to review that. All right, so for this one, where am I going to start? Which one is known? Oxygen, we know, is 2 negative, but I have 3 of those, so I have a total of 6 negatives here. What am I going to figure out next? Which one of those? What do you think? You had to take a guess. What would it be?
phosphorus.
Hydrogen. Hydrogen, in this case, is going to be positive. What is it? What's its charge always when it's positive?
1.
Plus 1, right? So we have 3 of them times 1 plus. So we have 1 plus for hydrogen. What is phosphorus going to be then? That's going to be 3 plus. Okay, and then over here we have HBr is what?
Hydrobromic acid.
Hydrobromic acid. We know our bromine, we already said 1 minus, and hydrogen is 1 plus. So looking at these, what is oxidized? Does anything become more positive? Does anything become more negative? No. So is this an oxidation reduction reaction? Trick question. I know. Okay. But it still gives you good practice of figuring out all the charges. Next one. Okay, so let's figure out our oxidation states here. Oxygen is going to be what?
2 minus.
2 minus. What is sulfur going to be right here?
2 plus.
Not 2 plus. How many oxygens do I have?
4 plus.
2. So since I have 2 at 2 negative, yeah, that has to be 4 plus. So we have 4 plus and 2 negative. Then I come over here, HNO3. What's SO2? Sulfur dioxide. What's HNO3?
Nitric acid.
The nitric acid. Okay, so I know my oxygen is going to be what?
2 minus.
2 negatives. So that's a total of 6 negatives there. Where am I going to go next? Hydrogen. What do I know hydrogen is?
+1.
+1. So I have 1 plus, and then plus whatever that is. So what is nitrogen going to be?
5 plus.
5 plus.
So you're basically, I know it's like a silly question, but you're basically doing the calculations that we did previously in your head, kind of?
Yeah.
Okay. All right.
Yeah, it's like I said, it goes back to the same thing of like writing compounds and figuring out charges that way. It's the same idea. All right, H2O we just did up there. Those are the charges. H2SO4, what's that called?
So yeah.
Sulfuric acid.
Sulfuric acid, yeah. So H2SO4, once again, oxygen, 2 negative charge, so we have a total of 8 negatives there. Hydrogen, what charge does it have? +1. But we have 2, so we have 2 positive there. So what does my sulfur have to be?
6.
6 plus, yeah. Then I come over here to NO. What is NO called? Nitrogen monoxide. We know oxygen is 2 negative, so that makes nitrogen what? 2 positive. Okay. So in this case, what is oxidized? What becomes more positive?
Sulfur.
Sulfur, yeah. What is reduced? The nitrogen. It goes from 5 plus to a 2 plus, so it's become more negative. So then our oxidizing agent is going to be what? HNO3. And our reducing agent is what? Questions?
What's that right there? On the top of,
Right here?
yeah.
That's just an X saying I'm solving for a 9.
Oh,
I can already set up a message you. Okay. Questions? We all have this 100%?
No, not at all.
Takes lots of practice.
Well, I get the concept. I think I'm just not quick enough with getting the
Getting the numbers?
Yeah.
Yeah, it comes with practice. This is one of those topics that using tutorials online would be to your advantage. Going and doing practice problems with oxidation reduction states would definitely be to your advantage.
Are you basically making each compound like try to equal 0?
If it's neutral, it has to equal to 0. But remember, like if we had something
If
like
it had like a charge, then you want it
NO3
to be
minus,
the charge.
it has to add up
Okay.
to that charge.
And then
So
they're
like
just-
this was, you had 6 minus. So whatever nitrogen is plus that has to equal
It has to
negative 1.
equal
So
negative
nitrogen
1.
has to be
Okay,
5
I
plus.
see. Okay.
Yeah.
That's where it comes into play where you memorize there's certain elements that have the same.
Yeah. So, and you really need to make sure that you look at the rules for determining oxidation numbers. Because if you don't know those, you're not going to know how to do this.
Is that the whole the oil ring?
Yeah, the order of
Oxidation is lost.
Yeah.
and definitions. Yeah, between the memorization of the rules and the definitions, if you don't know one of those, you're going to
Die.
Yeah. Okay, let's go on to balancing half reactions here.
Oh, for the exam. What? You study that?
No.
Anything.
But like everything that's on the
We are doing calculations. It just not those.
Okay. So the next thing that we're looking at is balancing oxidation and reduction half reactions. So we can actually balance these equations. These equations are not quite so simple as other equations to balance. So there's several steps for balancing redox reactions in your text. I don't have these written down from your textbook. What is the first step that it gives you? Okay, so step 1, sign oxidation numbers. We'll write these down and then we'll go step by step through this. What's the second step?
to separate the
Half reactions.
reactions.
And third?
Balance each reaction with respect to mass.
And then you do hydrogens or oxygens. What does it tell you?
For number 3,
This is
the following
electrons.
order balance all elements other than H2O. And you balance O by adding H2O and balance H by adding H+.
Wait.
And that's still step 3.
Oh, that's still step 3.
Yeah.
Okay. I just do it in my head, so I don't actually know how these steps work.
Oh.
Okay, so we have with oxygen and then with hydrogen, and is that all step 3?
Yeah.
Okay, so then you do charge.
Yeah, you balance each half reaction with respect to charge.
And add them together?
Yeah, make the number of electrons in both half reactions equal.
Then add them together so that
Yeah.
Okay. And then is double check probably, right?
Mm-hmm.
Okay. So there's a shorthand version. So we're going to do a few practices with this because this is another one of those things that it really takes a lot of practice to actually get this under your belt. And I know that most of, this is going to get put off to after the first exam, but you do still need to practice this quite a bit. So we are going to use this first problem here. As our starting point, and we're doing these in acidic solution. There's a difference between acidic and basic solutions when you're balancing the reactions, so it is careful, you do have to pay attention to this. Now, how many of you actually went to that website that I gave you there and looked at that walkthrough? Yeah, that's what happens. Okay, that website is going to be a valuable resource when you get lost, because I guarantee you're going to go home and you're going to be like, I have no idea what we covered in class, because this is a complicated subject. So please use that website. It does a really good walkthrough. It's a very good place to go to refer to. All right, so the very first thing that we want to do, they say to assign oxidation numbers. I actually kind of skipped this step, and I just divide them into half reactions just right away. So what I actually do is I look at this and I say, okay, these two things both have chromium in them, so they belong together. These two have nitrogen in them, they belong together. So I write these out. Into their respective half reactions. So you can divide the half reactions up just by looking at what belongs together. Now, ideally, you would also say, okay, one of these is oxidized, one of these is reduced. You can go through and you can identify which the oxidation reaction, what's the reduction reaction. But when you're balancing the equations, that really doesn't matter too much. It's pretty easy to just kind of do it without worrying about those definitions. But you can figure that out based upon what we've already talked about today. Okay, so you separate these out in half reactions. First thing you want to do is balance by mass. You want to make sure that you have the same number of chromiums over here as you do over here, same number of nitrogens on this side as you do over there. That's step 1. So to balance the chromium, what am I going to have to do? Put a 2 right there. So now my chromium is balanced. I'm just going to focus on this half reaction first. So I balance my chromium. The next thing I do is I need to balance my oxygens. And I do this by adding water to get those extra oxygens added in. I have 7 oxygens over here, but how many do I have on this side?
None.
None. So I have to add in how many things of water do you think?
7.
Too close. So I have to add in 7 waters over here. Now I have 7 oxygens there. I have 7 oxygens there. Oxygens are taken care of. The next thing is to balance my hydrogens. How do I balance hydrogens?
Add H+.
Add H+. So if I look at this, how many hydrogens do I have over here right now? None. How many do I have over there? 14.
Oh.
So I add in 14 hydrogens. So I have 14 H+ over here. Now everything is balanced by mass. My mass is completely balanced. What's my next step? What does it say? Balancing the charges. So now I look at this and I say, okay, my charges. I have 14 hydrogens that have a 1+ each. So I have 14+ right there. And a 2- right there. So I have a net of 12+. Everyone see that?
Mm-hmm.
Questions on that? Making up things myself. Okay. Then I come over here, and I have 2 chromiums with a 3+ charge. So that means I have a 6+ charge. Water is neutral. Don't have to worry about that. So over on this side, I have 12 positives. Over here, I have 6 positives. The only way I can balance balance charge is by adding electrons. I can't take hydrogens away. I can't take protons away. I can only add in electrons. So I'm going to have to add in electrons to this side to make it more negative. I want it to equal 6 plus. How many electrons would I have to add over here to make it equal 6 plus? 6. Yeah. So I'm going to add in 6 electrons over there. This half reaction is now balanced. Questions on how I did this?
I have a question, but it's okay. I put the 6 electrons.
You can put it in any order.
Okay.
I just was writing where I had room.
Okay.
I always forget the first time I do these to leave more room. So, yeah. Other questions on how I did this? This is fundamental. Without this, you're SOL. Figure it out. Do you all really not know what SOL means?
No.
I can't say it out loud. Sorry, out of luck. There we go. That's what I should refer.
Really? That's what it means?
You've never heard of SOL?
I don't text a lot, so I
It's not.
I don't text like that.
I don't text.
That's not texting. That came out long before texting
I
was
still
even
don't know
thought
it,
of.
okay? I still don't know it.
I've heard this since I was like 5.
I didn't. I'm sorry.
My family doesn't cuss, and so they use abbreviations.
Yeah, super obviously lost.
Yes, super obviously lost. There you go. Okay. On that side note, questions. Oh my God! Don't feel too embarrassed. I do. Okay, second half reaction. How are my nitrogens doing?
Looking good.
They're not good. They're not.
Are my nitrogens balanced?
Oh, yeah.
The nitrogens.
Yeah.
They're balanced. What do I need to balance next?
The oxygen.
Oxygens. How am I going to do that?
Put an H2O next to it.
H2O over here. So once the oxygens are now balanced, now what do I do?
Hydrogen balance.
Add a hydrogen.
I need to add a hydrogen over here, right? How many hydrogens?
2.
Okay, so are my masses all balanced? I have same number of atoms on both sides.
Yeah.
They should be. Okay, now I've balanced my charges. On my left side, what is my total charge? 1 negative, right? Because I just have that negative charge from here. That's neutral, so it's 1 negative.
Yeah.
What is my total charge over here?
0.
Look at it carefully. It's not 0.
2 plus.
I have 2 plus and
Minus a 1.
I have a 1 negative, 2 plus. So what is my total charge?
1 plus.
1 plus, right? So how am I going to get those to be equal?
You add 2 electrons to the left.
2 electrons to that right-hand side. Okay, now how's it look?
So you always try to equalize the positive one by adding electrons. You never. Oh, right. Never mind.
Only add
Yeah,
electrons.
you just said.
So you have to add them to whatever side will make it work.
Yeah. So it becomes
Oh, wait, no. It's 2 plus.
and you can't remove.
Oh, yeah, sorry. I see what you're yeah, we're not adding these now. They're 2 separate things. Questions on that side? Okay. Put your phone away. Next thing, over here, our next step is to balance the number of electrons from this equation to the number of electrons to this equation. These need to cancel out. We can't add these 2 together and have electrons left over. So electrons, we don't have them where we magically add them in the lab. It just doesn't work that way. So to get these 2 to have the same number of electrons, what am I going to have to do? Now I multiply.
Don't you multiply by 3?
I multiply this reaction by 3. I need to multiply one of these reactions by some number to get to the same number of electrons. So this whole reaction right here, the whole thing gets multiplied by 3. So it's important to remember that it is that whole half reaction gets multiplied by 3. So we rewrite this one. I'm just going to rewrite it down here. And it looks like that. So you multiply the whole thing by 3. Yes.
A lot. So we want to end up with 0.
You want to have 0 0 electrons. So you need to do something to cancel out all those electrons.
Isn't on this side, CO2, isn't that a negative
Over here? Yeah, you had a -1 charge here.
one? Should we multiply?
You'll be multiplying everything here by 3. You're looking at the number of electrons. Ignore you've already balanced all the charges.
Oh,
So ignore those charges. Yeah, you're only looking at the number of electrons. That's all you care about at this point. So the electrons have to cancel out from one equation to the other. That's all that's important now. How are we doing?
See.
Okay, so if you look at this now, I have this set up so that you can kind of see how things cancel out when you're adding this. So if something is on the left side and you have the same thing on the right side, they cancel out. Okay? So we're just adding this all together now. So when we're going through on this one, if you notice, we had 6 electrons right here, 6 electrons over here. Those cancel out. So you don't have to worry about them. So let's add this. I'll add the whole thing together here, and then we'll go through and do the cancellations. Can you tell us you guys are going to be using a lot of paper?
Yeah.
Okay, so when you add them together, this is the overall picture that you get. Now, this is just like any mathematical equation where if you have something on this side that is the same as something on this side, you can cancel it out. So if you look here, we have 6 electrons. So if I were to subtract 6 electrons from this side, they would cancel out with the 6 electrons over here. Likewise, if you look at your H pluses, you have 6 H pluses over here, 14 H pluses over here. So you take away 6 H pluses, and that leaves you with the 8 H pluses on that side. No H pluses on the other side. What else is the same on both sides? One other thing.
Water?
Water. You look at the water, we have 3 waters over here that we could take away from the 7 over here and get left with 4 H2O. Then everything else we just kind of drop down. And that is what we are left with. And we all now have a complete understanding of balancing half reactions, right? Yes.
Is it okay if, would it be harder if instead of just dropping everything down, if we were to reduce the hydrogens before you write it
Like
all out?
from here? Yeah, that's what I would do.
Because that's how I
I
did
only
it.
wrote this down here so everyone could see how they actually cancel out on both sides.
Okay.
So, yeah, I do a lot of this in my head when I'm doing these. So,
Oh.
now keep in mind, if you do stuff in your head and you mess up, you don't get the partial credit. But if you write stuff down and I can figure out where you messed up, if it's like, 3/4 of the way through, you're going to get more points than if you messed up 1/4 of the way through.
So would you recommend that I just write it all out instead of?
I would recommend doing that on an exam.
Okay.
Yeah. Yeah, in an exam, it's advisable to not skip steps in your head.
What if I were to just cancel the 6 H and just still show you the work?
That's fine.
Okay.
Okay, questions on that? All right, let's do a couple more. Okay, so for this one, what do you think my 2 half reactions are going to be?
H2O2 yields H2O.
Oh, going to
Yeah. So H2O2 goes to H2O, and what else?
-2
Okay, so there's our 2 half reactions. Let's start off with this one over here by doing the balance mass first. So balancing the mass, what do I need to do on this one? What's my first step that I'm going to do?
Balance
your waters.
Balance my oxygens.
I mean, oh yeah.
So I'm going to add in another water. because I already have water in here, I'm just going to put a 2. So I have 2 H2O there. Now what do I need to balance? Hydrogens. How am I going to balance those?
Add a H plus.
Add 4 H pluses, or no, 2. Sorry, 2 H pluses. So I have 2 H pluses there. How am I looking with the mass? My mass is now balanced. So now I need to balance my charges. I have 2 positive on the reactant side, 0 on the product side. So how am I going to balance the charges?
Add 2 electrons to the right, to the product.
So add 2 electrons over there, right?
It doesn't matter where you add them, or
You can put them anywhere over there.
okay.
As long as it's on this side. That's all it,
On the reactant.
on the reactant side.
Wait, can you explain why you did that?
We had 2 positive on this side. So our total charge here is 2 positive. Total charge over here, 0.
Oh, okay. Okay.
Yeah, the only way I can balance is by adding electrons.
Professor, why did you balance the hydrogens? Weren't they already balanced?
There was 2, there's 4.
Sorry, Cameron.
No problem. Okay, any other questions on this one? All right, next one. Over here. Are my ions balanced?
No.
No. So what am I going to do?
Add 2.
Add a 2 here. Okay, do I need to worry about oxygens or hydrogens?
No.
No. This one's easy. Okay, so now for this one, I need to add my electrons. My total charge on my reactant side is what? 2 minus. Over here, it's 0. So how am I going to balance those?
And 2 electrons.
2 electrons over here. All right. So these are both mass and charge balanced. Now let's look at the total number of electrons. Do I need to multiply these by something so that those can cancel?
No.
No, they already cancel, right? So I have 2 and 2 on both sides. So this one's kind of easy. So we have 2 I minus there. Got I2 plus 2 E minus here. So when you rewrite this, okay, so what can cancel out in my final equation right here? My electrons, can anything else? The iodines can't. Over here I have iodine ions. Over here I have iodine molecules. So this is that purple stuff that you see. Very different than the ions. Okay, so that's it, right? So this right here is your actual reaction. Okay, the third one. What are my 2 half reactions going to be? S to SO2. And what else? Okay, so let's start over here with this half reaction. Are there questions? Do you guys will see how we're getting the half reactions? Hopefully that's fairly clear. Okay, so over here, are my sulfurs balanced? Yes. What about oxygen?
No.
How do I balance my oxygen?
Add water.
Are we starting to get this a little bit better?
Yes.
Yeah.
Like I said, that when you get home, you're still going to go, look at that link. Okay, so we have our oxygens are balanced. What's the next thing we balance? Hydrogens, and how do I do that?
Add 4 H pluses.
4 over here. Now what's next?
Charges.
Charges, right? So we have a total of what charge on this reactant side?
2 minus the sulfur.
Sulfur's not, we're talking about solid sulfur. Or 2. There's no trick. I promise. 0. Yeah. Okay. Over here, what's our charge?
4 plus.
So how do I get these to equal out?
Add 4 electrons
To
To
your
right
reactant.
side.
products. Yeah. I do that all the time too. Okay. So this is this reaction. That one's now taken care of. Go over there to the NO3 minus to the NO. Our nitrogen's balanced. Yeah, how about oxygens?
No.
No, how do I balance oxygens? Add 2 waters, right? Because I have 1 oxygen already here. Okay, so I have my 2 waters there. Now what do I need to do?
Add my 42 plus to the left.
So add 4 H pluses to the other side. And then what? I need to balance my charges. What is my total charge over here?
Plus 0. No.
I have 4 pluses, 1 minus.
Oh, 4 plus.
3 plus, right? What about over here? 0. Okay, so how do I balance this?
Add 3.
Put that there so we don't get those confused. So I had 3 electrons over there. All right, so this is now completely balanced. And I look at these and I see I have a reaction with 4 electrons over here with 3 electrons over here. What do I do?
Multiply.
Yeah, basically, because that 12 is the least common denominator, right? So yeah, this one has to, this whole thing gets multiplied by 3. This whole thing gets multiplied by 4. So, that's one of them. And by the way, this is where most of the mistakes get made. Okay, so these are my 2 half reactions. When I line these up, I see that my 12 electrons are going to cancel. What else is going to cancel?
Your hydrogen.
My hydrogens, right? So this 12 is going to go away, and this 16 is going to become 4. What else cancels? H2O. So I have this 6 goes away here, and this becomes 2. Anything else? Not that I can see either. All right, so we rewrite this. And we end up with that. Questions on that one?
I have a silly question.
There are questions.
Okay, so let's try this. You know how you have a 4 plus chart up there in the very beginning?
Mm-hmm.
I always put it on the other side. So I put it with the reactants, not the products. So why is it with the because 4, I don't know. I don't understand why those 4 electrons go on the right side.
My 4 plus charge belongs to this side.
Okay.
It belongs to this product side. Because I have 4 plus right there. This side has 0 charge.
So when you want to put it on
The electrons?
yeah.
No, because remember, electrons are negative. So you have 4 minus plus 4 positive is 0.
Okay. I see it now.
You're probably not the only one who thought that, by the way.
Okay.
Okay, other questions on that one?
Does it matter how you write your final equation?
No,
Like if
they
it's
can, as
down
long as
or-
you have anything that's on the reactant side, it doesn't matter what order it's in. Conventionally speaking, you usually put like the water at the end, but I'm not going to dock you for that. That's nitpicky. And you can see I don't like to rewrite them. I want to get it as concise as I can.
Yeah.
Like, I don't want to rewrite it. Okay, the next thing is learning how to do these in a basic solution. It's not really any different. We just have 1 or 2 more steps. 4 more steps. I don't know how many steps they break down to in your book. Okay, so in a basic solution, at the very end, we tack on another step. What is it that you have to do additionally from the acidic ones? What's my additional step?
Instead of neutralizing it with the H plus, you're going to do it with an OH. And then the H plus and the OH are going to combine to form the water.
At the end, yeah.
Yeah.
So this final step. Okay, so let's look at this next reaction, and this one we are doing in a basic solution. So this tells us that we have to do the additional steps. Okay, so for this one, what are my two half reactions?
Copper yields
Cu
copper
to Cu2 plus, and what else?
nitric acid to
Nitric acid to what's NO? Nitrogen monoxide. Okay. So for these, copper is balanced. We don't have to worry about any oxygens, hydrogens, anything like that. What do I have to balance here before I can say this is done?
charge.
My charge. So this is 0, this is 2 plus, so how am I going to balance charge?
Add
2 electrons
to
to
the
the
product.
Okay. Questions on that one? That's about as easy as they come. Next one, HNO3. Are my nitrogens balanced?
No. Oh, yes.
Yeah, nitrogens are balanced. What about oxygen?
No.
How do I balance them?
Add 3 water. 2 DAC.
Add 2 waters over here. Then I have to balance my H's. How do I balance my H's?
Add 4 hydrogen.
3. There's one already.
Yeah. Oh, yeah.
So add 3 H pluses over here. Now I look at my charges. Bless you. What's my total charge on my reactant side?
Plus 3.
3 plus, right? Because I have 3 1 plus things. So total charge 3 plus over here. What about products? 0. So how do I balance this?
Add 3 electrons to the left side.
Okay. Questions? Yes, I'm picking up the pace on purpose. All right. So now we add these together. And oops, when I do this, before I can add them, how do I balance those electrons?
Oh, yeah, yeah. By each side. That side by 2.
This one by 3,
The other side by 2.
this one by 2. Okay, so for this one, when I add these together, what's going to cancel out? Electrons. Anything else? No, nothing else cancels out. So I end up. Bless you. Okay, I end up with this. Now, if this wasn't an acidic solution, it would be done. That would be my final answer. But because I said it's a basic solution, I now have one more step. I need to get rid of my hydrogen ions. The way I do that is I add however many hydrogen ions I have, I add the same amount of hydroxide ions into both sides of the reaction. So on both sides of the reaction here, I'm going to add in 6 hydroxide ions. And I just decided that because I had 6 hydrogen ions right here. These two things are going to combine to form 6 waters. So I have 6 waters now on that side. Let's call it right. Okay, so I add those together, and I got my 6 waters over here. Everything else basically stays the same. Now, when you look at this reaction, can something now cancel?
Mm-hmm.
What can cancel? My waters, right? Because now I have water on this side and on this side. So I'm going to get rid of my 4 waters from there, and that's going to reduce this to 2 waters here. Which gives us our final reaction of that. So the basic solution, by doing it in a basic solution, we have added on basically 2 extra steps. You have to add in a hydroxide, then you combine that with hydrogen to form water, and you cancel everything out. If you notice, this ends up with hydroxide ions in the solution. It's basic. That makes sense. If you end up with hydrogen ions in a basic solution, you should have red flags going off in your head. Hydrogen ions are acidic, so it doesn't work. Okay. Questions on that one? Okay, next one. Okay, so for this one, what are my two half reactions?
MnO4 MnO.
So we have MnO4 minus going to MnO2, and what else?
CN minus.
Okay, so we have our two half reactions. Let's start over with this one. Are my manganeses balanced?
Yes.
Yes. How about my oxygens? How do I balance those?
2H.
Two waters over here, and then I need to balance my hydrogens. How am I going to do that?
4H.
4 over here. So my total charge on this side is 3 positive. Total charge over here is what? 0, I heard. So how do I balance this? 3 electrons over on my reactants. Okay, questions on that one?
Professor, can you move that board that way? Because I can't see.
Okay, questions on that one? All right, over here we have CN minus, CNO minus. Are my carbons balanced?
Yeah.
Are my nitrogens balanced?
Yeah.
How about my oxygens? I am seeing tons of phones and hands today, and you wonder why you don't pass the class. Okay, what else?
Add a 2H plus to the product.
Add 2H plus over here on the right-hand side. Okay, what else then? Is everything balanced mass-wise?
Yes.
Yes.
Yes, what about charge?
No.
I have 1 negative over here, right? What's my charge over here?
2 plus.
2 plus and a 1 negative is what?
1.
1 plus. So how do I get those to balance out?
Add a single electron to
If I add 1 electron, I get a charge of 0, right?
add 2.
Yeah, I have to add 2. So I add 2 electrons over here. Okay, so now I'm mass balanced and I'm charge balanced. When I look at my numbers of electrons, what am I going to have to do in order to combine these to cancel out?
Multiply.
This one by 2, that one by 3, right? So this whole thing is by 2, and this whole thing over here is by 3. Okay, so these are my two half reactions that I'm going to add together, and I come down here. What's going to cancel out in these?
Your electrons.
My electrons are going to cancel. The hydrogen's going to cancel, right? I have 6 here, and I had 8 here, so this will become 2. What else? My water. So I have 3 here, comes over here, and makes that just a single water. So you add these together. Okay, so when you add them together, this is what you get. Once again, this is where you would stop if it was acidic, but it's not, it's basic. So since it is a basic solution, what do I have to do?
Add 2.
2 hydroxides to
Yeah.
both sides.
Yes.
Yeah, both sides. Okay. So I'm going to squeeze my 2 OH minus in over there. I really need to learn to leave more room. So I add 2 OHs to both sides. That results in this combining to be 2 waters. Now I can simplify my waters, right? So I had 1 over here, That's going to disappear, and this is going to be reduced to just one H2O. And that's what you get. Questions? Does it make a teeny bit more sense now than it did when you started?
Yeah.
I'll take a teeny. Lots of practice on this one. The good news is organic and biochem that go with this chapter are going to be really easy to study for, so you can focus all your attention right here. Okay, the next topic is activity series. Okay, so what purpose does the activity series serve? When I say activity series, what does that mean?
It's a list of metals in order of their reactivity.
Okay, so it's a list of metals in order of their reactivity. What does it tell me?
Determine which elements are easily oxidized.
Which ones are more easily oxidized? So if I'm doing reactions, why should I care about the activity series?
We can predict which one will replace which one.
You can predict if the reaction is going to occur, right? You'll know, is this reaction actually going to occur? So I'm trying to, is that projector red again?
Yep.
It's just toying with me today. I swear sometimes these things have personalities. Okay, so in your textbook, you have the activity series. This does not need to be memorized. You just need to know how to use it. So I will give you this information on the exam. I don't know this myself, so I do not expect you guys to memorize this. I don't think I ever had to memorize it, or if I did, I forgot. All right, so when we look at this table, the metals on the top, are they more easily oxidized or reduced?
Oxidized.
Oxidized, it says it right there, right?
Yes.
So 6 we're good. All right, so they're more easily oxidized up at the top, so they tend to lose electrons quite easily. They want to become more positive. The ones that are at the bottom are very difficult to oxidize. They want to gain electrons. They don't want to lose them. So these ones are very difficult. What this means is that if you have a reaction where lithium is going from lithium 0 to lithium 1+, that is most likely going to happen. It's more easily oxidized. So that's a very strongly occurring reaction. Gold, on the other hand, if this is the reaction that it is, it's going to be very difficult to do that. It will only do that in certain solutions. So if we look at different reactions, we can actually predict if they are going to react or not. So let's start off with our first one there. We have lead plus zinc acetate. What is zinc acetate?
C2. Yeah.
Okay, so we have Zn, C2H3O2, and lead. When this reacts, or if it reacts, it would go to that. Now, notice I ignore acetate.
Wait,
Why can I do that?
doesn't zinc have a set charge of 2 plus? It's an exception.
Yes, it does. Sorry, I forgot those in the parentheses. Okay, why can I ignore acetate? Is it a metal?
No. Polyatomic ion.
No, it's not. It's a polyatomic ion. So since my activity series has to deal with metals, and these are all in a solution, remember we're dealing with ions floating around. So I have acetate ions on this side, and I have acetate ions on this side. They're the same thing. They don't really exist as far as this reaction is concerned. I don't care about them. So I can completely ignore acetate and go just off of my charges here. So I would say that's zinc 2+. So this is the reaction that I'm trying to figure out if it is occurring. What I do is I look at my activity series and I say, okay, lead to lead 2+. Where is that located on the activity series?
Right before hydrogen.
Way down here, right? Where is zinc located?
Higher.
Higher. So is zinc going to want to go from a 2+ to a 0? Does it want to gain those electrons very easily? Which one of these should be oxidized? Is zinc going to be more easily oxidized, or is lead going to be more easily oxidized? Zinc. So would this happen in solution?
Yes, because electrons. Wait.
No.
This would not happen as much because the lead doesn't have that tendency to lose electrons. So the lead is perfectly happy right here. If zinc is there, it's higher up. Zinc is willing to be in the 2+ state. It's going to be the one in the 2+ state. Lead is going to want to be just like this. So the one that is higher up is the one that is going to want to have that positive charge. So this reaction does not happen. Okay, let's look at the next one. I have iron and aluminum oxide. What is aluminum oxide?
Al2O3.
Al2O3. Now, just like all the rest of these, you're going to discover that instead of the aluminum oxide, you could just write out the aluminum with its charge. Because once again, we're talking about ions. So my aluminum has a 3+ charge. If this actually goes through the reaction, I would have iron become 3+ and aluminum becoming just a solid metal. So when I look at my chart, where is the iron reaction located? Kind of in the middle, right? Is aluminum above it or below it? Above it. So which one of those is most likely to want to be in the positive state? Aluminum. So is this reaction going to happen? No, because aluminum wants to be in this positive state. It doesn't want to be reduced. So this would not actually happen. So this is a no-go too.
So do we just write no reaction?
No reaction. Yep.
If it was the opposite way, would it then be?
There would be a reaction. Yeah.
Okay.
Okay, the next one is silver nitrate. What is silver nitrate?
AgNO3.
AgNO3. We can, once again, ignore the nitrate. So it's just going to be Ag+, and it's reacting with nickel. If this occurs, it would go to silver. And what is nickel's charge? 2+. Do you have any questions?
So ignore anything that's not a metal, right?
Yeah, you can ignore the anion part. We're only interested in the metals. Okay, so silver. Where is silver located?
On the bottom.
On the bottom.
On the very bottom. Where is nickel located? Is it above it or below it?
Above.
So which one of these is going to want to be in the positive state?
Nickel.
The nickel. So will this reaction occur?
Yes.
Yes, this one will occur because nickel wants to go like that. So if it wants to do that, it's going to occur that way. Questions on that one? Okay, next one, sodium bromide. So I have sodium. What's the charge of sodium?
Plus.
+1 plus iodine. Iodine by itself, what is that? I2. And it would go to sodium plus I minus if this occurs. So where is sodium located? Pretty much at the top. Where is iodine located? Is it on here?
Nowhere.
No.
It is not on here.
Why?
It's not a
Why
metal.
did you keep iodine? And not
Iodine is one of those weird ones that can actually oxidize that. It's not on here.
The bromine.
Skip that one. Okay. I don't know where iodine would fall on that chart. So skip it. Skip the rest of them. They aren't on here, are they? Is there any other charts in the text that go over that? No.
Those aren't going to be on the test, right?
No, they won't be on the test. Okay, so that's going to be the end of the activity series because there's no other charts on there. That's fine. That's plenty of information for that chapter. Yeah, okay. So I'll make a note of that. We're going to stop there. I thought for sure that they would have that in the chart. Okay. Okay, so let's see here. That's the end of that. So we'll just do the metals. We're not doing the non-metals. Okay, so chapter 16 is a piece of cake, right? Okay, there's a couple of things I want to go over on the quiz real quick. We did pretty good on the calculation part. That was good. We've all figured out our calculators mostly. The part that I wanted to just review very briefly.
Oh, yeah.
I know, that was good. Yeah.
I know, I got tricked on that.
Was identifying conjugate acids and bases. For this one, remember, acids give away protons, bases gain them. So you have to look at the other side to see which one has given away the proton, which one has gained them. If you look at HCl, HCl becomes NaCl. It no longer has that proton. So this has to be an acid. That and hydrochloric acid is a strong acid. You should know right away that is an acid. This one is our base. What threw most of you guys was how to label the conjugate acid to conjugate base. The conjugate acid does not go with the acid. The conjugate acid goes to the base. So this is our conjugate acid. This is the conjugate base. Reason being, because remember that these reactions, unless you're dealing with a strong acid in this case, like in this case, but pretend it's not, most of these reactions go both ways. On the reverse reaction, this acts as a very weak base, this acts as a very weak acid. So they have acid, acidic, and basic properties. So you can't switch those labels around. So the conjugate acid goes with the base, and the conjugate base goes with the acid. Those are the conjugate acid-base pairs. So that threw some of you guys on the labeling. Same thing on the bottom one. When you look at this one, this should also there should be something here that screams to you that you're dealing with a base. Which one of these is going to be our base? NaOH, because it has the OH, screams base. So this is our base. That means this is the acid. What is the conjugate acid going to be?
H2O. NH3.
And what is our conjugate base? So these two go together, and these two go together. So we know this is the conjugate base because it has the nitrogen involved in it. So since the nitrogen over here was the acid, that one has to be the conjugate base.
Can H2O be the
If you have water reacting with water, water can be an acid and a base. But it has to be, water is, and the rest of these equations, if it's reacting with anything else, it's going to be either an acid or a base. It's up to you to determine basically which one it is that depends on the reaction. Okay, and then questions on this? The last thing I want to go over then for this was the last question. I threw that in there because you still need to be thinking about those, and I knew this last one was going to throw you guys. And I did it on purpose. This one should have been easy. What is that? That's hydrogen bonding. Yeah, hydrogen bonding. If you don't have hydrogen bonding down, it doesn't matter if you have all the rest. It still has to have hydrogen bonding. This last one, this is an interaction between a sodium bromide molecule and a water molecule. If you think of the intermolecular forces within them, or we have our different intermolecular forces. We have dispersion forces. We have, what are some of the other ones? I will give them away. Dipole. Is it a dipole?
Yes.
What do you have to have for dipole?
A polar molecule.
Polar molecule. Okay, we know this one's polar.
Yep.
What about this one? What is that?
It's an ionic.
Ionic, right?
And
Okay, so dipole's out. What else?
Iron dipole.
That's what it is, yeah.
I
What are the other choices?
Dipole-induced.
Dipole-induced dipole. For dipole-induced dipole, what do you have to have?
A polar.
Is it polar and a nonpolar? So for dipole-induced dipole, it has to be polar and a nonpolar. So you have to look at the characteristics of the individual molecules and figure out, what am I looking at? Because once I wrote down ionic, everyone went,
Yeah.
So you really have to analyze it. So this is ion dipole. So yeah, that's what that was. I don't think anyone actually got that one. So I threw everyone off successfully. That's an accomplishment. Not really. I don't purposely try and do that, but these are on the test, so that'll help you think through that on the test. Okay, and 5 minutes is not worth starting OCHEM. So questions for the test on Tuesday. It's how long it is. It's about 5 pages, I think.
It's written, right?
Yeah, it's handwritten.
You have the